In September 2003, a team of archaeologists was digging through the dirt floor of a limestone cave on a remote Indonesian island when they found something that should not exist. A human skeleton, but not like any human skeleton they'd ever seen. This person stood maybe 3 feet tall. Their brain was the size of a grapefruit, smaller than a chimpanzee's, and they'd been alive just 50,000 years ago, walking the earth at the same time as modern humans, with our big brains and sophisticated tools. The discovery sent shockwaves through the scientific community. Some researchers refused to believe it. Others called it the most important find in human evolution in half a century. The media gave these tiny humans a nickname that stuck: the Hobbits, real-life hobbits, and the controversy that followed would tear apart decades of what we thought we knew about human evolution. See, by 2003, scientists thought they had the human family tree pretty much figured out. Modern humans evolved in Africa, spread across the world, and outlasted our cousins like the Neanderthals. Simple story, neat timeline, case closed. Then a 3-foot-tall human with a brain 1/3 the size of ours showed up in a cave and broke everything. How could something like this exist? How could they survive with such tiny brains? Were they even human at all? And here's the part that really keeps scientists up at night. If these hobbits were real, what else might be out there that we haven't found yet? If you're settling in to explore this mystery with me, maybe drop a comment and tell me where you're watching from and what time it is. I love seeing Berlin at breakfast, Sydney at bedtime, all these different moments around the world connected by curiosity about our weird family history. The hobbits of Flores Island represent one of humanity's strangest family secrets, a branch of our family tree that nobody predicted, that challenges everything we think we understand about what it means to be human. Because here's the uncomfortable truth. We like to imagine human evolution as a straight line leading inevitably to us. Smart, tall, modern humans at the end of a long chain of progress. But the hobbits tell a different story. They tell us that human evolution was messy, unpredictable, and way stranger than we ever imagined. This isn't just about some extinct species that nobody's heard of. The discovery of these tiny humans forced scientists to rewrite textbooks, sparked fierce debates that turned colleagues into enemies, and opened up possibilities that seem like pure science fiction. What if human evolution didn't happen the way we thought? What if intelligence and brain size aren't as connected as we assumed? What if there were multiple versions of humanity living side by side in the ancient world, each adapted to their own strange corner of the planet? The research over the past 2 decades has given us some answers, but honestly, it's raised even more questions. We now know the hobbits were real. We know roughly when they lived and where they came from. We've learned incredible things about how evolution can transform a species when you isolate them on an island for hundreds of thousands of years. But we still don't know how they thought, how they lived, or what really happened when they finally disappeared. Tonight, we're going deep into the cave where it all started. We're going to meet LB1, the little lady whose skeleton changed everything. We're going to explore the lost world of Flores Island, where giant rats and pygmy elephants lived alongside 3-foot-tall humans. We're going to wade through the scientific battles, the theories, the mysteries that still haven't been solved, and we're going to ask the questions that matter most. What do the hobbits teach us about being human? And what does it mean that we shared this planet with them so recently, that their fires might still have been burning when our ancestors first arrived? The story starts in a cave, but where it leads is somewhere nobody expected. September 2003, the Indonesian island of Flores, a place most of the world had never heard of. A team of archaeologists was working in a limestone cave called Liang Bua, which translates roughly to cool cave in the local language. They'd been excavating there for years, finding the usual stuff: stone tools, animal bones, evidence of ancient human activity, nothing that would make headlines, Nothing that would change everything we thought we knew about human evolution. The team was led by Mike Morwood, an Australian archaeologist with a reputation for finding interesting things in unlikely places. He'd been working in Indonesia for years, convinced that the islands held secrets about human migration patterns out of Africa. His Indonesian colleagues, including Thomas Sutikna and Wahyu Saptomo, were equally committed. They'd been digging at Liangbua since 2001, carefully removing layer after layer of sediment, documenting everything, hoping for something significant. But nobody was prepared for what they found that September. 6 meters down in the cave floor, well below the levels where they'd been finding stone tools and evidence of modern human activity, they hit something different. At first it looked like a child's skeleton. Small bones, delicate structure, the kind of thing that makes archaeologists both excited and cautious. Child burials are relatively rare in prehistoric sites. They can tell you a lot about how ancient people viewed death and family. But they also require careful analysis because you're dealing with an individual who hadn't finished growing, except this wasn't a child. As they carefully exposed more of the skeleton, something seemed wrong. The skull was too robust for a child. The teeth were too worn, showing years of use. The pelvis, when they finally uncovered it, showed the characteristic shape of an adult female. And the limb bones, despite their small size, showed fully fused growth plates. This individual had finished growing. This was an adult who stood just over 3 feet tall. The team knew immediately they had something extraordinary. But what exactly? The first thought, the obvious thought, was that this must be a diseased individual, some kind of pathology that had stunted growth. Dwarfism, maybe, or some other genetic condition that had kept this person small. Ancient populations had genetic diseases just like modern ones. Finding a single individual with an unusual condition wouldn't be revolutionary. But as they continued excavating, more details emerged that didn't fit the disease hypothesis. The skull was small, yes, but it was perfectly proportioned. Not microcephalic, not showing any of the characteristic malformations you'd expect from most genetic disorders that cause dwarfism. The brain case was tiny, only about 380 cubic centimeters. That's roughly the size of a chimpanzee brain, about a third the size of a modern human brain. Yet this individual had clearly been using stone tools. The cave was full of them, found in the same layers as the skeleton. Sophisticated tools, not crude choppers, but carefully crafted implements designed for specific tasks. Whoever this person was, they'd been capable of complex behavior, despite having a brain that seemed impossibly small by human standards. The teeth told their own strange story. They were small, matching the overall body size, but they showed a wear pattern consistent with decades of use. When forensic analysis was completed, the estimate came back. This individual had been around 30 years old when she died. She'd lived a full adult life. She'd been using tools, eating food tough enough to wear down her teeth, surviving in an environment that required intelligence and adaptability. And she'd done it all while standing barely taller than a modern 6-year-old. The scientific team faced a choice. They could interpret this as a diseased modern human, an unfortunate individual with multiple pathologies that happened to combine in ways that created this unusual appearance. That would be the conservative interpretation, the one that didn't require rewriting any textbooks. Or they could accept what the evidence seemed to be suggesting, that this was something else entirely. A different species of human, one that had evolved in isolation on this remote island, developing its own unique adaptations to the local environment. The debate within the team was intense. These weren't amateur fossil hunters. They were experienced scientists who understood the extraordinary nature of what they were proposing. Claiming a new human species based on a single skeleton was risky. The history of paleoanthropology is littered with dramatic announcements that later turned out to be misidentifications or overly enthusiastic interpretations of limited evidence. But the skeleton designated LB1 for Liangbua 1 kept defying conventional explanation. Every analysis pointed to the same conclusion. This was an adult individual with proportions that didn't match any known pathology. The skull was weird, yes, but it was consistently weird. Not malformed, just different. The brain was tiny, but the brain case showed no signs of the asymmetry or structural abnormalities you'd expect from microcephaly. Most tellingly, the skeleton showed no signs of nutritional stress or systemic disease. The bones were well formed, properly mineralized, showing none of the markers you'd expect from severe genetic disorders that affect growth. Whatever had made this individual small, it wasn't starvation or disease. It was something intrinsic, something genetic, something that had been working properly to produce a fully functional adult at this unusual size. The team made their decision. They would describe this as a new species, Homo Floresiensis, after the island where it was found. They'd present their evidence, show their reasoning, and let the scientific community evaluate their claims. The paper was published in Nature in October 2004, just over a year after the discovery. The scientific world erupted. Some researchers were fascinated, immediately recognizing the implications. If this was real, if Homo floresiensis was genuinely a distinct species, it meant human evolution was far more complex than anyone had imagined. It meant multiple human species had existed far more recently than we'd thought. It meant our family tree had branches we'd never suspected. Other researchers were skeptical, pointing out that extraordinary claims require extraordinary evidence. A single skeleton, no matter how complete, wasn't enough to establish a new species. They demanded more fossils, more evidence, more analysis. But the public didn't wait for scientific consensus. The media seized on the story immediately. And they needed a name, something catchier than Homo floresiensis, something that would capture the imagination of people who'd never heard of paleoanthropology and didn't particularly care about the technical debates. Someone, nobody remembers exactly who, made the comparison that would stick forever. These ancient humans were small, living in a remote location, using sophisticated tools despite their size. Just like the Hobbits in Tolkien's Middle-earth, the nickname was perfect. Within days of the announcement, newspapers around the world were running headlines about the real-life hobbits discovered in Indonesia. The comparison wasn't scientifically rigorous, but it was instantly understandable. Everyone knew about hobbits. Now everyone wanted to know about these ancient humans who'd lived out their lives on a remote island, standing barely 3 feet tall, but apparently doing everything full-sized humans could do. Mike Morwood and his team were bemused by the nickname but didn't fight it. If calling them hobbits got people interested in paleoanthropology, that was fine. The important thing was that people were paying attention. The important thing was that resources would flow to Flores, that more excavation would happen, that the story of Homo floresiensis would continue to unfold, because LB1 was just the beginning. The initial discovery was spectacular enough, but what came next would only deepen the mystery. As the team continued excavating Liangbua, as they expanded their search to other sites on Flores, as they applied increasingly sophisticated analytical techniques to the fossils and artifacts, the hobbits would prove to be even stranger than anyone imagined. They weren't alone in that cave. They weren't a single aberrant individual who could be dismissed as an anomaly. They were a population, a successful population that had lived on Flores for tens of thousands of years, maybe hundreds of thousands of years. They'd survived, thrived, created a culture, used tools, hunted the bizarre animals that shared their island home. And then, at some point in the not-too-distant past, they'd vanished, leaving behind only bones and tools and questions. So many questions that scientists are still arguing about the answers 2 decades after that September day, when the impossible walked out of a cave and into our textbooks. Let's talk about what they actually found. Not the cave, not the initial shock of discovery, but the individual herself. The bones that would force scientists to rewrite their assumptions about human evolution. The skeleton that became known by the designation LB1, Liangbua 1, the first of the Hobbits. She was tiny, not just short but impossibly dramatically small. Stand her next to you and the top of her head would barely reach your waist. Maybe 3.5 feet tall, probably less, around 1 meter in height. That's smaller than most 6-year-old children today. Her entire body, from skull to feet, could fit comfortably in a space that most modern adults would find cramped. But here's what made researchers stop breathing when they first saw her. She wasn't a child. Every indicator showed she was fully grown, a mature adult who had lived for years, maybe decades. Her teeth were worn down from a lifetime of chewing tough foods. Her bones showed the kind of remodeling that only happens after years of use. The joints revealed patterns of stress and adaptation that accumulated slowly over time. This wasn't some unfortunate infant who died young. This was a functioning adult human who just happened to be spectacularly small. Her proportions were unlike anything in the modern human family. Long arms that seemed slightly too long for her body, reaching down past where you'd expect. Large feet, disproportionately big compared to her tiny legs. Not freakishly large, but noticeably out of scale with the rest of her skeleton. Her hands showed a mix of features that confused everyone. Some elements looked primitive, ancient, like they belonged to human ancestors from millions of years ago. Other features seemed surprisingly modern. The shoulders were particularly strange. The structure was primitive, more similar to early human ancestors than to modern humans or even Neanderthals. This suggested her people hadn't been doing the same kinds of overhead activities that shaped modern human shoulders. No systematic spear-throwing, probably. No habitual reaching and lifting in the ways that leave distinctive marks on bone structure. But the real puzzle, the thing that kept researchers arguing for years, was her brain. When they measured the cranial capacity of that tiny skull, they got a number that seemed impossible. Approximately 400 cubic centimeters, maybe a bit more, maybe slightly less depending on measurement techniques, but somewhere in that range, 400. To put that in perspective, modern human brains average around 1,350 cubic centimeters, more than 3 times larger. Neanderthals had brains even bigger than ours. Even our ancient ancestors from 2 million years ago had brains around 600 to 800 cubic centimeters. But 400? That's smaller than most estimates for Lucy, the famous Australopithecus skeleton from Ethiopia, who lived more than 3 million years ago. That's roughly the brain size of a chimpanzee. And yet, the archaeological evidence around her suggested something that didn't make sense with a brain that small. Stone tools, fire use, systematic hunting. These weren't activities that chimpanzee-sized brains were supposed to accomplish. This was the cognitive capacity for abstract thought, for planning, for cultural transmission of knowledge, all somehow packed into a brain case the size of a large grapefruit. The team carefully documented her age at death. The bones told a story of someone who had lived long enough to reach full skeletal maturity, but probably hadn't made it to old age. Best estimates put her around 30 years old when she died, give or take. In evolutionary terms, in the harsh environment of an isolated island, 30 years represented a full life. She would have been through multiple seasons, raised children possibly, accumulated knowledge about her environment and passed it on to younger members of her group. What killed her? The bones don't tell us directly. There's no obvious trauma, no signs of violence or catastrophic injury. She might have died from disease, from infection, from any of the 1,000 natural causes that ended lives before modern medicine. Or maybe she died in a way that left no mark on bone, drowning perhaps, some internal illness. The cave sediments preserved her remarkably well, but they couldn't preserve the final moments of her life. What they did preserve was evidence of how she lived. The wear patterns on her bones suggested a life of constant physical activity. Walking, climbing, probably scrambling over rough terrain on a daily basis. Her leg bones show the kind of development that comes from a lifetime of movement on uneven ground. Her feet, those disproportionately large feet, were clearly adapted for gripping and balance. Maybe for climbing trees, maybe for navigating the rocky landscape around the cave. Her teeth revealed a diet that was tough and fibrous. The enamel was worn in patterns that suggested she ate a lot of plant material, probably roots and tubers that needed serious chewing. But there were also signs that she ate meat, that her people were processing animal proteins regularly. This matched what archaeologists found in the cave deposits. Bones of the pygmy elephants, evidence of butchery, stone tools sharp enough to slice through hide and separate meat from bone. Finding a skeleton this complete was extraordinarily rare. Most fossil humans come to us in pieces, a jawbone here, a skull fragment there, maybe if you're lucky, a few limb bones that might belong to the same individual. Complete skeletons are precious beyond measure because they let you see the whole picture. How did the arms relate to the legs? How did the skull connect to the spine? What did this individual actually look like when they were alive? LB1 gave researchers that complete picture. Not perfect. Some bones were missing or damaged. But enough remained to reconstruct her entire body plan, to understand her proportions, to see how all the weird features fit together into a functioning individual. You could look at her skeleton and imagine her moving through her world. Walking on those large feet, using those long arms to steady herself on rocky slopes. That tiny head containing just enough brain to navigate a complex social and physical environment. She became the reference point for everything that followed. Every other hobbit bone found in the cave was compared to her. Every theory about where these people came from had to account for her bizarre combination of features. Every debate about whether they were a real species or some kind of abnormality returned to her bones, to the physical evidence that couldn't be dismissed or explained away easily. This tiny woman, this impossible survivor, this person who shouldn't have existed according to everything we thought we knew about human evolution, she changed everything, and she wasn't alone. Here's the thing about scientific discoveries that change everything. The first finding might be extraordinary, but it's what comes after that tells you whether you've stumbled onto something real or just encountered a bizarre anomaly. When the Liangbois team found LB1, that tiny skeleton curled up in the cave floor, they knew they had something unprecedented, but they also knew the questions would come fast and brutal. Was this just one weird individual? Some unfortunate person with a severe developmental disorder? A child, maybe, mistaken for an adult? The skeptics were already sharpening their knives, so the team kept digging, and what they found next changed everything. Within months of the initial discovery, more bones started emerging from the cave sediments. First, scattered teeth, then fragments of leg bones, then a jaw, and another jaw, then parts of skulls, then more teeth, more fragments, more pieces of a puzzle that was getting bigger and stranger with every shovel of dirt. By the time the team finished their initial excavations, they had identified remains from at least 9 different individuals. Some estimates push that number to 15, though fragmentary preservation makes exact counts difficult. But here's what mattered. These weren't all from the same time period. The fossils came from different stratigraphic layers, different moments in the cave's history spanning thousands of years. This wasn't one unusual individual. This was a population a sustained breeding population that had lived in or around Liangbua for millennia. The discovery that really sealed the deal came from a specimen designated LB6. Just a jaw, but what a jaw. Small, robust, with the same distinctive features as LB1's mandible. Tiny teeth, primitive chin structure, dimensions that matched the original skeleton almost exactly. LB6 came from a different part of the cave, a different sediment layer, probably a different time period separated from LB1 by thousands of years. Two individuals, same unusual features, different eras. The odds of this being coincidence, of two people with the same rare pathology ending up in the same cave thousands of years apart, were astronomical. This had to be a real population. But the team wanted more than just jawbones and scattered teeth. They needed to understand variation. Every population has variation. Individuals differ in height, in build, in skull shape, in 1,000 subtle ways. If the hobbits were a real species and not just diseased modern humans, they should show normal population variation. Some individuals slightly larger, some smaller, some features more pronounced, others less. The kind of diversity you'd expect in any healthy breeding population. And that's exactly what the Liangbua fossil showed. The specimens varied, but they varied within a consistent range. All small, all showing the same basic skeletal architecture, all clustering around dimensions that were way outside the normal range for modern humans, but consistent with each other. Statistical analysis of the bones showed a pattern of variation typical of a stable population, not the random weirdness you'd expect from pathological individuals scattered across time. The teeth were particularly revealing. Dental morphology is incredibly useful in identifying species because teeth preserve well and show clear hereditary patterns. The Liangbua teeth were consistently small, with distinctive wear patterns and root structures, but they also showed the kind of individual variation you'd expect in a population where people are eating similar foods, living similar lives, and passing on similar genes generation after generation. Some individuals had slightly larger molars. Others showed more pronounced canine development. All normal variation. All within a consistent pattern that screamed real population, not pathological anomaly. The age distribution was fascinating too. The fossils represented individuals of different ages. Young adults, older individuals with heavily worn teeth, possibly even juveniles, though juvenile bones are harder to identify definitively. This suggested complete life cycles playing out over thousands of years. People being born, growing up, reproducing, aging, dying, all in the shadow of this limestone cave in eastern Flores. For years this was the picture. A small population of tiny humans living in and around Liangbua from at least 95,000 to 60,000 years ago. An isolated group on an isolated island, evolving in their own weird direction while the rest of humanity went about its business on the mainland. Strange but contained. A curiosity of island evolution. Then in 2014, everything got stranger and older. A team working at a site called Mata Menge, about 70 kilometers east of Liangbua, found something extraordinary. More Hobbit fossils, but these weren't from 95,000 years ago. These fossils were dated to roughly 700,000 years ago. 700,000 years. The Hobbits weren't just an isolated population that evolved recently. They were an ancient lineage that had been living on Flores for almost 750,000 years. The Mata Menge specimens included teeth and a fragment of jawbone. Small teeth, remarkably small. Even smaller than the Liangbua specimens, suggesting that if anything, the Hobbits might have gotten slightly larger over time rather than smaller. The jaw fragment showed the same primitive features as the later specimens. Same basic architecture, same weird combination of ancient and modern traits. But 700,000 years older. This discovery rewrote the entire story. The Hobbits weren't some recent aberration. They were one of the most successful human populations in history. Think about it. 700,000 years. That's longer than Neanderthals existed as a distinct species. That's longer than modern humans have been around by a factor of 3. For comparison, the entire history of agriculture is only about 10,000 years. The Roman Empire existed for maybe 1,000 years. The United States has been around for less than 250. These little people, living on their isolated island, maintained a stable population for 700,000 years. They survived climate shifts that would have destroyed civilizations. They weathered volcanic eruptions, sea level changes, everything that geological deep time could throw at them. And they did it while being barely a meter tall, with brains the size of a grapefruit. Suddenly, the Hobbits weren't just an interesting footnote in human evolution. They were evidence of something profound, evidence that there are multiple ways to be successful as a human species, that big brains and tall bodies aren't the only evolutionary solutions to survival, that under the right circumstances small can work just as well as large, and maybe even better. But this revelation raised as many questions as it answered. How did a human population get to Flores 700,000 years ago in the first place? What were they before they became hobbits? And most intriguingly, what happened to them? Why did a population that had survived for 750,000 years suddenly vanish? Flores sits right in the middle of Wallacea. That's the name scientists give to the zone of islands between mainland Asia and Australia. It's named after Alfred Russel Wallace, the naturalist who independently came up with the theory of evolution at the same time as Darwin. Wallace spent years exploring these islands in the 1850s, and he noticed something that bothered him. The animals on islands just west of this zone were Asian. Tigers, monkeys, elephants, all the creatures you'd expect to find in Southeast Asia. But move east, even just a few islands over, and suddenly everything changed. The animals became Australian, marsupials, different kinds of birds, an entirely different evolutionary heritage. The invisible line between these two biological worlds runs right through the Indonesian archipelago. On one side, Asia, on the other, Australia. And sitting right on that line, right in the transition zone, is Flores. This placement meant the island received occasional visitors from both worlds, but it was never connected to either, and that's the key to understanding everything that happened there. See, during the Ice Ages, when sea levels dropped dramatically, land bridges appeared all across the world. Japan connected to mainland Asia, Britain connected to Europe. Indonesia's western islands, places like Java and Sumatra, they connected to the Asian mainland, forming a vast landmass scientists call Sundaland. In the east, Australia and New Guinea merged into a supercontinent called Sahul. Animals could walk freely across these temporarily united lands, mixing populations, preventing the kind of isolated evolution that creates really strange adaptations. But Flores never connected. Even at the absolute lowest sea levels of the deepest ice ages, when the ocean dropped 400 feet below current levels, Flores remained an island. The channels separating it from neighbouring land masses stayed deep. Too deep to walk across. Too deep even to wade through at low tide. If anything was going to reach Flores, it had to cross open ocean. And for most animals, that's basically impossible. So how did anything get there at all? That's one of the great mysteries of island biogeography. The answer is that very occasionally, through some combination of luck and disaster, animals do make it across water barriers that should be impassable. A massive storm surge might wash a group of animals clinging to debris out to sea. A floating mat of vegetation torn loose during a flood might drift for days or weeks, with small creatures trapped on it. A pregnant female might swim or be carried across a narrow strait, establishing an entirely new population on the far shore. These events are vanishingly rare. But over millions of years, rare events accumulate. And when they do happen, when some lucky or unlucky creature finds itself washed up on an isolated shore with no way back, evolution gets very creative very fast. The ancestors of Flores' Hobbit humans would have needed to cross at least 15 miles of open ocean, possibly much more depending on their route. This wasn't a casual wade through shallow water. This was a genuine sea voyage, whether intentional or accidental. It required either sophisticated watercraft or an incredibly fortunate accident involving storm debris or floating vegetation. The fact that human ancestors made it to Flores at all tells us something remarkable about their capabilities. Either they were smart enough to build boats and navigate deliberately to new lands, or they were resilient enough to survive being swept out to sea and washing up on distant shores. Either possibility is fascinating. Either possibility suggests these were not simple-minded primitives, but resourceful, adaptable creatures capable of surviving the most extreme circumstances. And when they arrived, they found a world unlike anything their ancestors had ever known. Flores was an evolutionary carnival, a place where the normal rules had been suspended. The island's most famous resident before the hobbits were discovered was the stegodon. These were relatives of elephants, but they'd undergone something called island dwarfism, shrinking over generations until they were barely the size of a cow. Full-sized elephants need enormous ranges and massive amounts of food. On a small island with limited resources, smaller individuals survived better, reproduced more successfully, and gradually the entire population miniaturized. But while the stegodons were shrinking, other animals were doing the opposite. Flores was home to giant rats the size of small dogs. Massive stalks stood over 3 feet tall with heavy bills perfect for cracking bones and scavenging meat. They were predatory birds, essentially, filling the niche that would normally be occupied by much larger carnivores. And lurking in the undergrowth were Komodo dragons, real-life monsters straight out of mythology. 10-foot-long lizards that hunted in packs, using bacteria-laden bites to bring down prey much larger than themselves. This was the world the first human ancestors encountered when they somehow made it to Flores. No large mammalian predators, but plenty of other dangers, limited resources, isolated environment, and a community of creatures that had already been evolving in isolation for millions of years. The island was an evolutionary laboratory, and the hobbits were about to become its most remarkable experiment. Because here's what's truly fascinating about island evolution. It's not random. It follows predictable patterns. Large animals tend to shrink, conserving energy in resource-limited environments. Small animals tend to grow, freed from predation pressure that keeps them tiny on mainlands. Brains, which are metabolically expensive to maintain, often get smaller unless intelligence provides a survival advantage that outweighs the energy cost. And populations develop unique features found nowhere else on Earth, adaptations to their specific island circumstances that would be useless or even harmful anywhere else. Flores had been running these evolutionary experiments for millions of years before the first human ancestors arrived. The dwarf elephants, the giant rats, the predatory storks, all of them were products of this isolation. They were the result of creatures arriving on the island and then being reshaped by the unique pressures of life in this lost world. And when early humans finally made it across those ocean barriers, they were about to join the experiment. They were about to become another data point in the grand natural laboratory of Flores. They were about to become hobbits. The question that would haunt scientists for decades was simple. Would the same rules that had reshaped every other animal on Flores also apply to humans? Could evolution do to us what it had done to elephants and rats and storks? The evidence was about to suggest something that seemed impossible. Yes, it could. On most continents, evolution plays out on a gigantic stage. Herds can migrate for hundreds of miles. Predators can follow the seasons. If a drought hits one region, animals can push into another, searching for better grass, better water, better chances. But on an island, the world is small and the walls are real. There are no new valleys just beyond the horizon, no great migration routes waiting over the next ridge. You have what you have. A strip of forest, a ring of coastline, a few rivers that never quite reach the size of a real mainland river. Food is limited, space is limited, and escape is impossible. Under those conditions, evolution starts doing something strange. Biologists call it insular dwarfism, island dwarfism. It sounds like fantasy, but it's one of the most predictable patterns in nature. Take a large animal, isolate it on an island for long enough, and it very often shrinks. We see this again and again in the fossil record. On Wrangel Island in the Arctic, cut off from mainland Siberia by rising seas at the end of the last ice age, mammoths got trapped. On the mainland, mammoths were titans, huge, towering, weighing several tons. But on Wrangel, something different happened. Over thousands of years, generation by generation, the mammoths got smaller. By the time they finally vanished about 4,000 years ago, they were the size of big horses. Still impressive, but miniature compared to their continental cousins. In the Mediterranean, the story repeats with almost comedic consistency. On islands like Crete, Cyprus, Sicily, ancient hippos became hippos in name only. Fossils show dwarf hippopotamuses the size of pigs, wobbling around landscapes their ancestors would have dominated. Elephants too shrank down into island dwarfs, some barely taller than a large dog. These weren't sick animals. They weren't juveniles that died young. They were healthy adults of fully evolved dwarf species, entire populations that had taken a different evolutionary path, sculpted by the same handful of pressures. Limited food, no way to leave, often fewer large predators. On a big continent, being huge is a useful strategy. Large bodies store more energy. They deter predators. They can move long distances to track scattered resources. But on an island, those advantages turn into liabilities. If food is scarce and patchy, a massive body becomes an expensive luxury. You need more calories just to stay alive. When a dry season hits, or a storm wipes out a patch of vegetation, the big animals starve first. Smaller individuals, the ones who can survive on less, suddenly have a survival advantage. They're the ones who live long enough to reproduce. They're the ones who pass on their genes. Over many generations, this quiet arithmetic of survival pushes the whole population towards smaller size. Skeletons shorten, skulls shrink, limbs become more compact. The animals are still the same basic kind of creature, still mammoth, still hippo, still elephant, but redesigned for a tighter, harsher world. Predators matter too. On continents, being small can mean being easy prey. On islands where the top predators never made it across the water or died out later, there's less pressure to stay large and intimidating. Safety no longer comes from sheer bulk. It comes from needing less, moving less, risking less. And then there's the simple fact of space. On a small island, territories can't expand forever. You can't keep needing more land to support more massive bodies. Populations that shrink can pack more individuals into the same area without exhausting the ecosystem. So natural selection nudges them, step by step, toward a more efficient body plan for a confined stage. This is the logic many researchers think may have shaped the hobbits of Flores. If Homo floresiensis descended from a larger-bodied ancestor, perhaps an early Homo erectus population that managed to raft or island hop its way to Flores, then once they were there, they were trapped in an evolutionary pressure cooker. A hot volcanic island with rugged terrain, limited fertile patches, and no easy escape. Large-bodied humans would have needed a lot of calories, meat from the local pygmy stegodons, roots and fruits from the forest. In good years, that might have been fine. In bad years, those appetites would have been deadly. But the smaller individuals in the founding population, the ones who could function on fewer calories, who could ride out lean seasons, they would have had better odds. Over thousands of years, that tiny advantage compounds. The population shifts, the average height falls, brain volume tracks body size downward. A new form of human emerges, perfectly calibrated for life on a demanding, isolated island. This idea isn't just speculation. Flores itself is full of island-size experiments. Alongside the Hobbit's bones, researchers have found evidence of giant storks, oversized lizards, and most famously, enormous rats. Creatures that, on the mainland, are small or modest in size seem to swell when they're freed from certain threats. When the big mammalian predators are absent, small animals don't need to stay tiny and hidden. They can get larger, slower, bolder. This is the counter-phenomenon to island dwarfism, island gigantism. So you get both sides of the evolutionary coin on a single island. The big things shrink, the little things grow. The ecosystem compresses toward the middle, meeting around a new balance point set by the island's resources, its lack of predators, its cramped geography. On Flores, that balance may have meant human-like creatures just over a meter tall, sharing their world with giant rats the size of small dogs and birds tall enough to look a hobbit in the eye. It's a haunting picture, a miniaturized humanity walking through a world where everything else has been resized to match. For many scientists, this pattern, big mammals shrinking, small animals growing, all on a remote island, is one of the strongest arguments that Homo floresiensis wasn't a diseased modern human, but a true island dwarf species. Their height, their body proportions, even their small brain can be interpreted through the lens of insular dwarfism, evolution doing what it always does on an island with limited food and no escape, trimming away excess until only what's necessary remains. But here's where the story gets complicated. Island dwarfism neatly explains the hobbit's small stature. It can even account for some of their skeletal anatomy, like the shortened limbs and reduced body mass. Yet, when researchers look closely at their bones, they see features that don't fit cleanly into a simple, shrunk Homo erectus story. The shape of the wrist bones, the proportions of the feet, the structure of the shoulder and pelvis. Some aspects look surprisingly primitive, more like much older hominins than like a scaled-down version of our more recent ancestors. It's as if Flores didn't just shrink its humans. It preserved or reawakened traits from a deeper past. That's why the debate continues. Was island dwarfism alone enough to sculpt all of Homo floresiensis's oddities? Or are we looking at something even stranger? An island dwarf descended from a very ancient lineage, or a mosaic of traits shaped by forces we still don't fully understand? The honest answer is, we don't know yet. What we do know is that Flores fits the classic pattern of an evolutionary island laboratory. Limited resources, no easy exits, strange giants and stranger dwarfs. In that secluded world, evolution played with size like a sculptor with clay, carving out a human form that seems familiar at first glance, then uncanny the longer you look. The hobbits might be the most dramatic example we've ever found of what happens when our own lineage is thrown into that laboratory and left there, undisturbed, for hundreds of thousands of years. The first time researchers measured the skull of the Liangbois skeleton, there was a moment of genuine disbelief. The cranial capacity of LB1, the best-preserved hobbit, was about 400 cubic centimeters. That's roughly the size of a chimpanzee's brain. Less than a third of the average modern human. Smaller even than some much older human ancestors who lived more than 1 million years before her. On paper, that just didn't make sense. For more than a century, paleoanthropology had been telling a fairly simple story. Over time, brains get bigger. Bigger brains mean more intelligence. More intelligence means better tools, more complex behavior, richer culture. It was such a neat linear narrative that it began to feel like a law of nature. and then a tiny skull from a cave in Flores quietly whispered, "Are you sure? Because here's the weird part. This chimp-sized brain didn't belong to some primitive, barely human creature scraping by at the edge of survival. Around LB1's bones, archaeologists found stone tools that looked familiar. Not chimpanzee familiar, human familiar. Sharp flakes carefully struck from cores, points suited for cutting and piercing, evidence of butchering animals, including pygmy elephants, the stegodons of Flores. Some of the tools resembled technologies associated with much larger-brained humans elsewhere. They were simple compared to modern engineering, but they were not crude. This is what made Homo Floresiensis so controversial from the beginning. The skull said tiny brain. The archaeology said competent toolmaker, effective hunter. The two didn't match the old script. For years, scientists had used brain size as a rough stand-in for cognitive ability. It wasn't perfect, everyone knew that, but it seemed to work well enough for big-picture trends. Early hominins with smaller brains used simpler tools. Later species with bigger brains invented more complex technology and, eventually, art and symbolic culture. Yet here, in a cave on a remote island, was a very small-brained human doing things many researchers had assumed required something like a modern-sized brain. Planning hunts, processing carcasses, possibly using fire, surviving for hundreds of thousands of years in a challenging island ecosystem full of unique predators and scarce resources. That's why the brain became the center of the Hobbit debate. The bones of the arms and legs could be explained by island dwarfism. The small body made sense in an environment where resources were limited. But the skull refused to sit quietly. When researchers began analyzing the internal shape of LB1's brain case using CT scans and virtual reconstructions, the story became even stranger. Yes, the Hobbit brain was small, no getting around that, but its internal organization didn't look like a shrunken, primitive ape brain. In some ways, it looked surprisingly advanced. Certain regions, especially in the frontal and temporal lobes, appeared relatively expanded for such a tiny brain. These areas are associated in modern humans with planning, problem-solving, and aspects of language and social cognition. The overall pattern was compact but complex. Not the brain of a simple-minded creature, but a brain packing a lot of function into a very small space. This was not what many researchers had expected to see. To some, the only way to reconcile a chimp-sized brain with modern-like tools and behavior was to assume that something had gone wrong with this particular individual. Maybe LB1 wasn't a typical member of a separate species at all. Maybe she was just a modern human with a severe developmental disorder. The leading candidate was microcephaly, a condition in which the brain and skull fail to grow to normal size. People with microcephaly have much smaller heads, and in some cases cognitive impairments. If LB1 was a microcephalic Homo sapiens, then the small brain was an anomaly, not a revolutionary challenge to the brain size narrative. At first glance, that idea had some appeal. The brain was tiny. The face looked unusual. The body was small and oddly proportioned. It was tempting to file everything under pathology and move on. But as more data came in, the pathology theory began to fray. Comparative studies looked at skulls from microcephalic humans and matched them against LB1. The shape wasn't quite right. Microcephalic skulls tend to show distinctive distortions, shortened vaults, altered base shapes, characteristic asymmetries. LB1's cranium, though small, was proportioned in a way that looked normal for itself, consistent, as if it had grown according to its own species' blueprint, not as a damaged version of ours. The rest of the skeleton told a similar story. The wrists, the feet, the shoulder joints, they weren't just scaled-down modern human bones. They retained primitive features seen in much older hominins, alongside more derived traits. The proportions were coherent, integrated, evolutionarily patterned. Not random, not what you'd expect from a severe developmental disorder. Over time, more Hobbit individuals were found in the cave. They shared the same small size and many of the same anatomical quirks. It became harder and harder to argue that everyone at the site just happened to have the same rare pathology. The simpler explanation was that this is just what Homo floresiensis looked like. And if that was true, then the brain puzzle couldn't be dismissed as a medical curiosity. It had to be faced directly. Could a brain the size of a chimpanzee's support flexible tool use coordinated hunting and long-term survival on a tricky island? Could it sustain something like human-level problem-solving, at least within the Hobbit's ecological niche? Modern neuroscience offers a quiet, unsettling answer. Maybe. We now know that brain size by itself is a blunt instrument. Within our own species, some people have significantly smaller brains than others, yet function perfectly normally. There are documented cases of individuals with far less brain tissue than expected leading ordinary lives, their brains seemingly reorganized for maximum efficiency. Across species, brain efficiency and wiring patterns often matter more than raw volume. Birds, for example, have much smaller brains than mammals of similar intelligence, but their neurons are denser and arranged differently. Some corvids and parrots, with brains the size of walnuts, can solve puzzles that stump primates. Even among ancient humans, the relationship between brain size and behavior isn't simple. Neanderthals had, on average, larger brains than modern humans, yet they did not develop exactly the same kind of symbolic and technological explosion seen in Homo sapiens. Bigger isn't always better in a straightforward way. It's about how the brain is organized, what it's optimized for, how it's used. Seen in that light, a tiny but efficiently wired hobbit brain is not impossible. Unsettling to our old assumptions, yes, but not impossible. Maybe Homo floresiensis evolved to do more with less. On an island where calories were scarce and bodies got smaller through dwarfism, brains may have shrunk too, not because intelligence wasn't useful, but because energy was precious. Instead of expanding endlessly, their brains may have become compact, specialized, streamlined for the particular challenges of Flores. If that's the case, then the hobbits are more than a quirky side branch of our family tree. They're a challenge to a story we've been telling about ourselves for a long time. The story that intelligence is always about bigger brains, more neurons, more volume, the straightforward upward line. The little skulls from Liangbua suggest something else. That cognition can take multiple shapes, that evolution can find different solutions to the same problems, that a creature half our size with a brain a third as large might still have been, within its world, clever, adaptable, quietly effective. We don't yet know exactly how smart Homo floresiensis was. We may never know in the way we'd like, but their existence forces us to loosen our grip on simple equations. Brain size equals intelligence, bigger equals better, small equals primitive. On a sleepy island in Indonesia, a handful of tiny skulls are whispering a different possibility, that we've been underestimating not just them, but the flexibility of minds themselves. And if our cousins from Flores could bend the rules of brain and behavior, then another question follows naturally, like a shadow. What else about human evolution have we been oversimplifying? The first scientific paper on The Hobbit had barely finished printing before the knives came out. On one side you had the discoverers, cautiously but clearly suggesting something extraordinary. Not a strange modern human, not a child, a different kind of human altogether. On the other side you had colleagues reading those same measurements and photographs and saying, absolutely not. This isn't a new species, this is a mistake. Or worse, an illusion created by disease. In a way you can't blame them. If Homo floresiensis was real, it meant rewriting entire chapters of human evolution. It meant accepting that as recently as 50,000 years ago, there were tiny, stone tool-using humans living on a remote island in Indonesia, while big-brained Homo sapiens were spreading across the globe. For some researchers, that leap was simply too far, so they reached for a simpler explanation: disease. The first big idea was microcephaly. Microcephaly is a condition where the brain and skull fail to develop to normal size. People with microcephaly can have smaller heads, altered facial proportions, and developmental differences. To some skeptics, LB1 looked exactly like that: small brain, unusual skull shape, short stature, case closed. If LB1 was just a microcephalic modern human, everything went back to normal. No new species, no rewriting of textbooks, just a tragic individual whose bones happened to fossilize in a cave. Microcephaly wasn't the only suggestion. Other pathologies lined up like suspects in a police lineup. Some argued for cretinism, a severe form of congenital hypothyroidism often caused by iodine deficiency. In modern populations, cretinism can stunt growth and affect bone development, creating short limbs, altered skull shape, and intellectual disabilities. On a remote island with limited resources, that seemed plausible. Others suggested Laron syndrome, a rare condition involving growth hormone insensitivity. People with Laron syndrome are very short, with specific cranial and facial proportions. It could, some thought, explain LB1's small size and some skull features without inventing a new human species. Still others reach for Down syndrome as an explanation, trying to match cranial shape, facial structure, and brain size to known modern conditions. If LB1 had Down syndrome, the argument went, then again, there was nothing new here. Just a modern human with a recognizable disorder. Underneath all these proposals, there was a common impulse: keep the story simple. Don't multiply species if you can explain everything with one. In science, that instinct is often useful, but sometimes it can be blinding. The problem was that LB1 refused to behave like a patient in a medical textbook. Microcephaly in modern humans doesn't produce the exact pattern of features seen in LB1. The proportions of the face, the jaw, the brow, the vault of the skull, the internal shape of the brain case, these didn't quite line up with known microcephalic individuals. When researchers did detailed comparisons, measuring angles, volumes, curvatures, they kept finding the same thing. LB1 was small, but it wasn't small in the way microcephalic humans are small. Cretinism has its own skeletal signatures, particular changes in long bones, specific irregularities in growth plates, characteristic deformities in the spine and pelvis. Many of those simply weren't present. Laron syndrome has a different pattern. Down syndrome another. Each pathology has a fingerprint, and LB1's bones refuse to leave clear prints of any of them. And then there was the biggest problem of all for the pathology hypothesis. LB1 was not alone. As more bones were studied from Liangbois, a picture began to emerge of not one strange individual but a small population. Other leg bones, arm bones, jaw fragments, and teeth from different individuals all pointed in the same direction. People about a meter tall, with similarly small body mass, similar proportions, similar primitive features. If this was disease, it had to be the same rare disease, expressed in the same way, in multiple individuals over a span of time, in a single cave. That was possible in theory, but it was increasingly unlikely, and the skull itself, for all its smallness, had a curious mixture of traits. Some parts looked surprisingly primitive, closer to Homo erectus, or even earlier human ancestors. Other parts were more modern. It was like finding a car that was the size of a go-kart, with an engine from the 1920s, but with headlights from the 1990s. Not broken, just different. The tools scattered around the bones made things even stranger. These weren't clumsy, desperate tools made by someone profoundly impaired. They were well-made stone flakes and blades, used for butchering animals, processing plants, and perhaps even working wood. Some appear to have been produced using techniques that require planning, coordination, and repeated practice. If LB1 had lived with severe cognitive disabilities, and if the population as a whole had been pathologically compromised, who made those tools? Who hunted the stegodon, the dwarf elephant of Flores? Who controlled fire? Who managed to survive generation after generation on a difficult island full of predators, volcanoes, and shifting coastlines? The more carefully the bones and tools were studied, the more the pathology explanations began to fray. But the debate did not cool down. It heated up. Papers and counter-papers flew back and forth. Some were strictly technical, full of measurements and statistics. Others were more personal, accusations of sloppiness, of bias, of wishful thinking crept in between the lines. At conferences, discussions about the Hobbit could turn sharp, even hostile. Senior researchers who had built their careers on a particular view of human evolution now found it challenged by a tiny skeleton from an island cave. The stakes weren't merely academic. If Homo floresiensis was real, it meant our family tree was bushier, stranger, and more geographically widespread than many had imagined. It meant small-bodied humans with tiny brains could still make complex tools and survive in difficult environments. It threatened some comfortable assumptions about brain size, intelligence, and what it meant to be advanced. Resistance in that context was almost inevitable. What gradually changed minds was not a single dramatic discovery, but a slow accumulation of evidence. More detailed CT scans of LB1's skull, comparative studies of microcephalic and cretinous skeletons, reanalysis of limb proportions and joint structures, new dates for the fossils and tools, additional remains from Liangboar and hints of similar finds elsewhere on Flores. Again and again the same pattern emerged. The Hobbit bones were internally consistent. The traits fit together in a coherent way, as if shaped by long-term evolution, not random disease. They looked like a small, well-adapted population with its own evolutionary history, not a cluster of modern humans struck by multiple, identical medical conditions. Bit by bit, the pathology theories grew quieter. Not gone entirely. Science rarely erases ideas completely, but no longer at the center of the conversation. Instead, attention turned to a deeper question. If these people were not diseased modern humans, who were they? In that sense, the great Hobbit debate is more than a quirky argument about one set of bones in one cave. It's a window into how science actually moves forward, not through instant consensus, but through friction, through competing ideas tested against the same stubborn facts, through personal pride and skepticism on one side and patient accumulation of evidence on the other, through arguments that feel, in the moment, messy and uncomfortable, but which, over years, push our understanding closer to reality. Homo floresiensis, if that name truly belongs to the hobbits of Flores, force scientists to confront their own assumptions about what a human is supposed to look like. It reminded everyone that evolution doesn't care about our categories or our neat mental diagrams of progress. It takes whatever paths local conditions allow, even if those paths lead to tiny, tool-using people on a forgotten island. In the quiet of Liangboar, the bones never changed. They simply lay there, patient, while humans above ground argued about what they meant. Eventually, as always, the bones won. For now, scientists circle around two main possibilities. They're not mutually exclusive, and they're both strange. The first is the simplest on paper. It says the hobbits were descendants of Homo erectus, the same hardy, long-legged humans who spread out of Africa nearly 2 million years ago. Homo erectus was the great traveller of early human history. Tall, strong, with relatively big brains and stone tools good enough to conquer half the old world. We know erectus reached nearby islands. Their fossils show up in Java, just a few island hops west of Flores. So the idea goes like this. Sometime in the distant past, a small group of Homo erectus made it to Flores. Maybe they rafted accidentally on mats of vegetation, swept out to sea by floods. Maybe they were better seafarers than we give them credit for. However they arrived, once they were on Flores, they were trapped. And that's where island evolution starts to play its tricks. On a small island with limited food and no giant predators to run from, being big and hungry stops being an advantage. It becomes a liability. Over thousands of generations, natural selection can flip its preferences. Smaller bodies need fewer calories. Shorter limbs are cheaper to maintain. Tiny adults can live on tiny resources. We see this over and over in island ecosystems. Elephants shrink into dwarf elephants. Hippos become pygmy hippos. Deer become miniature deer. Why not humans? Under this theory, Homo erectus slowly shrank. Bodies got smaller. Brains got smaller too, because brains are expensive to run. The result, after hundreds of thousands of years of isolation, would be something like Homo floresiensis, a pocket-sized version of a world traveller, custom-built for a modest island life. This theory is comforting in a way. It keeps the hobbits inside the familiar story. They're weird, but they're weird in a way we can explain using rules we already understand. Big humans move onto a small island. Big humans become small humans. Case closed, except it might not be. Because when researchers started looking closely at hobbit bones, especially the famous skeleton LB1, they noticed something unsettling. Some features did look like a scaled-down Homo erectus. The overall proportions of the skull, certain details in the jaw. But other parts of the skeleton did not fit that neat pattern at all. They looked older, much older. The wrist bones, for example, had shapes more like those of very early hominins and even great apes than like Homo erectus or modern humans. The shoulders and upper arms looked primitive too, suggesting a different way of moving, maybe even climbing, that had more in common with much earlier ancestors. The feet were long and flat, with a strange mix of modern and ancient traits. The combination was like finding a laptop built with some parts from a modern machine and some parts from an early typewriter. It worked, but it didn't follow any straightforward upgrade path. This led to the second, more radical idea. Maybe the hobbits didn't come from Homo erectus at all. Maybe they descended from something even more primitive, a species that left Africa before erectus, carrying a more ancient body plan with it. Under this scenario, very early hominins, perhaps relatives of species like Homo habilis, or even an unknown African ancestor, managed to wander out of Africa long before the textbook out of Africa waves we usually talk about. They travelled across Asia in small scattered groups, and one of those groups, against all odds, reached Flores. Isolated there, they evolved in their own direction for an immense stretch of time, preserving some primitive features that had long vanished everywhere else. For a while, this idea seemed too extreme. It required a kind of deep migration that the fossil record didn't obviously support. But then, in 2014, another site on Flores whispered an answer. At a place called Matamenge, on a dry, open landscape about 50 kilometers from Liangboa, researchers dug into layers more than 700,000 years old. In those ancient sediments, long before the hobbits of Liangboa, they found hominin fossils, parts of a jaw, a few teeth, fragments of skull. Small, very small, smaller even than LB1 in some respects, and yet clearly related. The teeth had shapes and proportions that placed them in the same weird family as Homo floresiensis. That meant something profound. Whatever the Hobbit story was, it didn't begin 100,000 years ago, or even 200,000. It stretched back at least 700,000 years on Flores alone. That's plenty of time for an ancestor to shrink, yes. But it also meant the Hobbit lineage had been evolving in isolation far longer than anyone had guessed. Long enough to preserve or even redevelop some surprisingly primitive traits. The Matamengi fossils didn't neatly solve the debate. If anything, they deepened it. Their tiny size supports island dwarfism. Their shapes hint at deeper, older roots. Some researchers read them and say, yes, this is dwarf Homo erectus pushed to its evolutionary limits. Others look at the same bones and say, no, this looks like something that branched off from the human tree before erectors ever set foot in Asia. And quietly, in the background, another question grows larger. If the hobbits do descend from a pre-erectus ancestor, that would mean some form of early human left Africa far earlier and spread far wider than we've ever confirmed. The usual story says, first came Homo erectus out of Africa, then much later Neanderthals, Denisovans, modern humans, a tidy sequence like beads on a string. The Hobbit debate suggests the string might be tangled. Maybe there were multiple overlapping migrations, some successful for a while, then lost, some leaving only faint genetic echoes, others, like the Hobbits, leaving bodies but no living descendants. The skeletons of Flores sit right on this fault line in our understanding. Their primitive traits hint that the out of Africa story is less a single wave and more a series of pulses, surges, retreats, a restless movement of different human species testing the edges of the world long before ours ever appeared. If that's true, then the Hobbits are not just an odd island experiment. They're a surviving chapter of an earlier forgotten age of exploration. And then there's the most tantalizing possibility of all. If Flores, a single island out of thousands in Southeast Asia, held an entire unknown human species for more than 700,000 years, what else might be out there? The region is full of deep caves, dense forests, steep limestone hills, and islands that have barely been explored archaeologically. In nearby Luzon, in the Philippines, scientists recently discovered yet another mysterious human, Homo luzonensis, with its own strange mix of primitive and modern traits. Another island, another odd, small-bodied hominin, another hint that the human story in this region is far from simple. It's not hard to imagine that other human species once lived, and perhaps still lie undiscovered, in the hidden corners of island Southeast Asia. Bones waiting in flooded caves, teeth sealed in ancient riverbeds, tools buried beneath layers of ash and time. The hobbits of Flores might be the first of these island ghosts to step into the light, but they may not be the last. For now, their origin remains an open question, balanced between dwarf Homo erectus and a deeper pre-erectus ancestry. The truth may be some combination, or something we haven't yet imagined. What's certain is that however they began, the hobbits walked a long, lonely evolutionary path, far from Africa, far from the crowded centres of our story. And in doing so, they quietly rewrote what it means to be human, and how many different ways there might have been to arrive at something almost like us. To understand the hobbits of Flores, you have to slow everything down, forget skyscrapers, forget cities, even forget villages. Imagine instead a cool limestone cave on a green volcanic island, the sound of distant water, the flicker of fire against rock. For at least 50,000 years, maybe longer, this was home. Liang Bua isn't just a hole in a hill, it's a layered memory. Every centimetre of sediment is a page in a book the hobbits never wrote, but somehow left behind anyway. When archaeologists dug down, they didn't just find one skeleton and a few random bones. They found a pattern of life, scattered through the layers, stone flakes, broken tools, burned bone, ash lenses, piles of animal remains. The same kinds of things you'd find if you sifted through the trash of any long-term campsite. But these weren't the leftovers of modern humans. These were the daily signatures of a people barely over a metre tall. The stone tools are the first clue to how they lived. They're simple, but not crude. Sharp flakes, points, scrapers, carefully chosen cobbles. Not the elegant blades of the later Homo sapiens, but not mindless rock bashing either. Someone knew what they were doing. And those someones had very small hands. The tool sizes, the wear patterns, the way they fit with the bones we found all point to the same thing. A tiny-bodied hominin making tools scaled to its own anatomy. Yet the toolkit itself doesn't shrink in ambition. The hobbits were doing the same core things our ancestors did. Cutting, scraping, piercing, preparing food, working plant materials, but they were doing it with downsized bodies running on downsized brains. That's where the puzzle gets interesting. The tools from Liang Bua look in many ways like the tools made by much larger-brained hominins elsewhere. Homo erectus in Java, early modern humans in other parts of Southeast Asia. Flake and core technologies that are standardized enough to suggest teaching, imitation, shared technique. It's as if the hobbits had inherited an ancient technological language and kept speaking it long after they'd shrunk. Food was at the center of that language. The bones found in the cave read like a menu from a lost world. Most famous are the remains of Stegodon, a kind of dwarf elephant that once roamed Flores. Their bones are split, scorched, and marked with cut lines. Thin incisions where stone edges slice through tendon and muscle. Spiral fractures where long bones were snapped, probably to get at the rich marrow inside. Stegodon weren't tiny to the hobbits. Even though they were island dwarfed, they were still massive animals. Taking one down wasn't something a single 3-foot hominin did on a casual afternoon. The butchery marks and the distribution of bones suggest coordinated effort. An animal driven into a ravine or bog, isolated, finished off, then dismembered and carried in pieces back to the cave. Alongside the Stegodon bones are the remains of giant rats. Not storybook fantasy rats, but real scientifically documented ones. Some the size of small dogs. Their bones too bear the telltale signatures of being processed for meat. Cut marks near joints, patterns of burning. It seems the hobbits didn't mind mixing megafauna with something closer to hand-sized prey. Large game when they could get it, small game as a constant backup. Everywhere among these bones are traces of fire, thin ash layers, charcoal flecks, burned rock, blackened fragments of bone. Not a single catastrophic burn, but repeated low-level use over thousands of years. Enough to indicate that fire wasn't an occasional visitor. It was a resident. What exactly they were doing with that fire is still debated. Some researchers see organized hearths, distinct burned patches where groups might have sat, cooked, talked, repaired tools. Others see a less tidy pattern, repeated opportunistic fires, lit wherever it made sense. Either way, the message is the same. The hobbits controlled fire well enough to bring it into the cave, use it to process meat, probably roast those giant rats, and light up the darkness. This alone says a lot about their capabilities. Fire use demands planning. You have to gather fuel. You have to maintain a flame or know how to rekindle it. You have to understand, even if not consciously, that raw meat becomes safer and softer when exposed to heat. All of this suggests a cognitive world richer than their brain size would lead you to expect. That leads naturally to the question everyone wants to ask, but no one can answer directly. Did they have language? We don't have fossilized conversations. We have to infer from anatomy and behavior. The hobbit's brain was small, but its shape, from the endocasts we can reconstruct, shows some expanded areas associated in us with planning and social behavior. Their stone tools show consistency over long periods, hinting at cultural transmission. Their hunting strategies imply coordination. None of this proves language in the fully modern human sense, but it's hard to imagine silent, purely instinctive cooperation sustaining complex hunting and fire use over tens of thousands of years. Maybe their speech, if they had it, was limited. Fewer words, simpler grammar, more dependence on gesture and context. Or maybe it was deeply expressive in ways we can't even imagine, tuned to a slow island life, a small social world, a cave that never moved. What we can say is that Liangbua doesn't look like the work of solitary, uncommunicative individuals. It looks like a home with rules, habits, and shared knowledge. Social organization in such a world would have been shaped by scale. A species that's small physically probably lived in small groups numerically. Perhaps 20, 30 individuals, a band of relatives and long familiar faces. In a space like Liangbua, everyone would know everyone else's business. Firelight evenings spent repairing tools, processing meat, grooming, maybe teaching children how to strike flakes from stone or how to read the calls of birds outside the cave. Those evenings had another purpose: protection. Flores was not a gentle island. Lurking in its forests and river valleys were one of the most formidable predators alive today: Komodo dragons. On Flores, as on nearby islands, these giant lizards hunted large prey, scavenged carcasses, and occasionally tested anything that moved. Komodo bones found in and around Liangbua suggest that the relationship between hobbits and dragons was complicated. Some remains show cut marks and burning, hinting that at least sometimes the hobbits were not just potential prey, but active hunters or scavengers of the dragons themselves. Imagine the calculation involved in approaching a reptile with venomous saliva, razor teeth, and a body longer than your entire group's tallest member. It would require planning, courage, or perhaps desperation, or all three. At the same time, Komodos would have been a constant threat. A sleeping hobbit child and a hungry lizard make for a tragically one-sided encounter. The cave, elevated and defensible, with its smoky, fire-lit interior, might have been chosen partly to keep dragons at bay, staying in groups, keeping embers glowing at the entrance, listening for the scrape of claws on rock. These habits could have been as important to survival as any stone tool. If you try to reconstruct a single day for a hobbit of Flores, based on all this evidence, it goes something like this. Dawn filters into the cave mouth. The fire, banked overnight, is coaxed back to life. A few embers, dried plant matter, careful breath. Smoke curls toward the ceiling. Outside, the forest wakes too. Bird calls, insect hum. The distant shuffle of larger animals moving through undergrowth. Small hunting parties gather their stone tools. Flakes tucked into fibre belts. Simple wooden spears tipped with sharp rock. They head out along familiar paths, down towards streams where stegodon sometimes drink, or into thickets where giant rats burrow. They follow tracks, listen for movement, read the landscape with eyes trained from childhood. Back in the cave, others stay behind. The elderly, the very young, perhaps a few adults preparing plant foods, stripping fibres, tending the fire. When a carcass is brought back, the whole space becomes an improvised workshop. Cutting, scraping, cracking bones, roasting strips of meat over the flames. Stone tools are resharpened, new flakes are struck. Some efforts fail, some succeed, but over years the successful methods become the norm. As evening falls, the outside world grows more dangerous. Komodos move more freely in the cooling air. The hobbits gather closer to the fire, bodies pressed against the cave floor for warmth. Stories might be told here, if they had stories. Maybe not in words we'd recognize, but in gestures, sounds, shared glances. Lessons are passed down. Where to find water in the dry season, which paths to avoid when the dragons are hungry, how to tell from a single footprint whether a stegodon is worth following. Then darkness deepens. The cave glows orange and red. Beyond its entrance, the island returns to shadow and breath. For tens of thousands of years, this cycle repeated. Hunt, gather, make, teach, watch, sleep. A tiny species in a small cave on an isolated island, carving out a life with fire, stone, and fragile social bonds. They never built cities. They never left written records. But in their tools, their bones, and the burn marks on fossilized elephant and rat, they left something else. Proof that even with a brain the size of a grapefruit and a body smaller than a modern child's, a human cousin could master an island, tame fire, and stand its ground in a world of giants. When scientists first announced Homo Floresiensis to the world, they thought the story ended long before we arrived. Early dating suggested the hobbits disappeared around 12,000 years ago, still recent in geological terms, but comfortingly distant from modern humans. Neat, separated, no overlap. Then the dates changed. Improved dating techniques pushed the last known hobbit bones back much further in time. Instead of 12,000 years, the youngest fossils from Liangbois now seem to be around 60,000 years old. The stone tools associated with them continue a little longer, maybe to around 50,000 years ago. And something very important was happening in that part of the world around 50,000 years ago. Modern humans were on the move. Genetic evidence and archaeological finds suggest that Homo sapiens reached Southeast Asia somewhere between 45,000 and 50,000 years ago, maybe even a little earlier. By that time, our species had already left Africa, met Neanderthals in the Middle East, probably encountered Denisovans in Asia, and was spreading fast toward Australia. To get to Australia, or at least to the ancient continent we call Sahul, humans had to pass through the islands of Indonesia. Not necessarily every island, but through that maze, that stepping stone world of land and sea that included Flores. Put those dates side by side and the picture gets very quiet and very intense. Homo Floresiensis, last traces around 50,000 years ago. Homo sapiens, arriving in the region around 50,000 to 45,000 years ago. The window of overlap might have been narrow, a few thousand years, maybe less, maybe more, or maybe, in some secluded valley that left no fossils, the hobbits held on longer than we think. But even with our current data, the possibility is hard to ignore. Two kinds of humans sharing one small island world. What happens when that occurs? We have hints from other times and other places. When modern humans moved into Europe, Neanderthals vanished within a few thousand years. In Asia, Denisovans seem to fade from the record after contact with our species. In each case, there's evidence of interbreeding, but also of replacement. Sometimes the replacement might have been indirect. We might not have needed constant violent conflict. Our bigger networks, broader toolkits, and fast-spreading ideas could have outcompeted smaller, more localized populations. If one species can gather more food from the same landscape, can have more babies that survive, can heal more injuries, it slowly takes over, even if no one ever lifts a spear in anger. But sometimes, of course, we did lift spears. So imagine Flores, around 50,000 years ago. On one side, a population of small-bodied, small-brained, island-adapted humans who'd been there for hundreds of thousands of years. On the other, newly arrived Homo sapiens with long-distance knowledge networks, more flexible technology, and a brain that had been fine-tuned for symbolic thinking, planning, and social complexity. Maybe they never met. Maybe the hobbits had already dwindled away before the first modern human footsteps crunched across the island's volcanic soil. That's the simplest, safest explanation. But it's not the only one. There's nothing in the known timeline that absolutely forbids overlap. If even a few hobbit groups persisted after 50,000 years ago in parts of Flores we haven't yet excavated, then encounters become not just possible, but likely. Modern humans move, they explore, they follow rivers and coastlines, track animal herds, and push just a little farther than the generation before. At some point, someone would have rounded a bend in the forest and seen something impossible. Not an animal. Not quite. Not a human either. Not quite like any human they had ever seen. Small, hairy, walking upright, carrying tools, with faces that were somehow familiar and alien at the same time. What happens next? Do you run? Do you hide? Do you laugh? Do you throw a spear? Do you try to speak? We don't know. The bones and stones are silent. They can tell us when a species lived, how it walked, what it ate. They can occasionally hint at violence, a healed fracture, a cut mark, a skull fracture that never healed. But Flores has not yet given us a clear scene of battle or of friendship between hobbits and humans. Instead, we have something softer, stranger. We have stories. The people of Flores have long told tales of small, hairy forest dwellers called the Ebu-Gogo. According to local tradition, Ebu-Gogo were about 1 meter tall, walked upright, and spoke in a murmuring, unclear language. They were clever but not wise. They could mimic human speech, but not quite understand it. They stole food. Sometimes, it's said, they stole children. They lived in caves in the deep forest, on the fringes of human settlements. Most strikingly, some versions of the legend say the Ebu-Gogo survived until surprisingly recent times. Not tens of thousands of years ago, but a few hundred. Stories describe villagers finally driving them away, burning them out of their caves. Of course, folklore is not a fossil record. Myths evolve. They absorb fears, jokes, moral lessons, and borrow details from neighbouring cultures. It's risky to draw a straight line from a modern legend back to an ancient species. Many anthropologists are cautious, and rightly so. And yet, humans are very good at remembering. Oral traditions in Australia may preserve memories of sea level rise that happened over 7,000 years ago. Stories among some Native American groups seem to encode volcanic eruptions that date back thousands of years. Cultural memory is not perfect, but it is often more durable than we expect. So the question lingers in the quiet. Could the Ebu-Gogo stories be distorted echoes of real encounters with another kind of human? Maybe what began as direct experience, small people in the forest stealing crops, muttering in a strange voice, slowly shifted into legend as the last of those beings disappeared and only the stories remained. Details blurred, motives changed, but the core image survived. Little, hairy, almost humans sharing the island. Not quite friend, not quite animal, not quite us. We may never know. But the timing is intriguing. Tiny humans on Flores until at least 50,000 years ago. Modern humans entering the region soon after. Local legends of tiny forest dwellers passed down into the present. Somewhere in this tangle of dates and tales and bones, there is a real ending for Homo Floresiensis. We just haven't fully uncovered it yet. Why did the hobbits vanish? One possibility is natural catastrophe. Flores lies in a restless part of the world. Volcanoes, earthquakes, tsunamis. These are not rare visitors. A major eruption could have wiped out key hobbit populations, poisoned water sources, and transformed forests into ash fields. In a small, fragile species already confined to a single island, one bad eruption at the wrong time might have been enough. Another possibility is competition with us. Even without direct aggression, modern humans may have simply outperformed the hobbits. We could have hunted the same animals more efficiently, gathered more plants, expanded our camps into their territories. Over generations, the smaller, slower breeding population loses ground. Births fail to keep up with losses. One by one, the valleys fall silent. And then there is the darkest possibility, deliberate extermination. Humans are capable of extraordinary empathy, but also of brutal othering. A different-looking people on our land might have been treated as monsters or pests, not cousins. If that happened, the evidence would be almost impossible to distinguish from any other kind of death, tens of thousands of years later. Or perhaps the answer is not one thing, but many. A changing climate, a volcanic event, shrinking habitats, new predators, humans, arriving with unfamiliar tools and strategies, each factor by itself survivable, together over centuries quietly fatal. However it happened, by the time history as we know it began, the hobbits were gone. Only their bones in Liangbua, their stone tools scattered in ashen sediment, and perhaps a few flickering legends remained. Yet the overlap question, did we meet them? Did we speak? Did we fear them or learn from them? Refuses to let go. It hovers at the edge of the lamplight where science ends and possibility begins. For now, Flores keeps its secrets, but the idea that, for a brief moment in deep time, our ancestors might have walked the same forest paths as these tiny humans, heard their voices in the dark, watched their fires across a valley. That possibility lingers, like an ember that refuses to go out. And it leads to a deeper question. If hobbits once shared our world, what do they still have to teach us about being human? For more than a century, scientists quietly assumed they knew what counted as human. Big brain, tallish body, long legs built for distance walking, tools that got more and more complicated over time. A single, simple story. Awkward ape becomes clever person, then spreads everywhere. The hobbits shattered that story in an instant, because if Homo floresiensis really is its own species, then all those comfortable assumptions start to crumble. Here was a tiny creature with a brain closer in size to a chimpanzee than to us, living on a remote island, yet making stone tools sharp enough to butcher animals. Here was a population that survived for hundreds of thousands of years in a demanding environment, hunting dwarf elephants and giant rats, navigating steep ravines and underground caves. Small body, small brain, but clearly doing something very human. So what does that make them? The discovery on Flores quietly forces us to rethink what being human actually means. Maybe it's not about brain volume. Maybe it's not about height, or having a chin, or even looking much like us at all. Maybe it's about something subtler, the ability to adapt, the ability to share skills, the ability to inhabit a landscape with knowledge instead of just instinct. By that measure, the hobbits fit right in. Their bones say primitive. Their tools say capable. Their survival over immense stretches of time says successful. They blur a line that used to feel sharp, the line between ancient ape and modern human. Instead of a clean boundary, we're left with a foggy twilight zone, where different kinds of hominins did different mixtures of human-like things. And in that twilight, our family tree stops looking like a straight trunk and starts looking like a tangled thicket. Before Flores, you could still pretend human evolution went roughly like this. One species at a time, each one replacing the last. After Flores, that illusion is harder to maintain. The hobbits lived at a time when, somewhere on the planet, there were also modern humans, Neanderthals and Denisovans. 4 kinds of humans, maybe more, existing within the same broad window of time. And Flores wasn't alone in changing the story. In 2019, in Calao Cave in the Philippines, researchers uncovered another surprise: fragmentary bones and teeth that didn't match any known species. Too small in some ways, too strange in others. They named it Homo luzonensis, another island, another small-bodied hominin, another potential cousin that nobody had predicted. Suddenly Southeast Asia, which had once seemed like a quiet backwater on the map of human origins, began to look like a whole archipelago of experiments. Different islands, different evolutionary paths, some groups getting larger, others shrinking, some retaining ancient skeletal features, others developing peculiar new ones, all of them adapting to local conditions in ways we're only beginning to understand. Homo floresiensis, Homo luzonensis, Denisovans, Neanderthals, modern humans, not a neat line, a crowded family reunion. And this crowding changes how we think about ourselves. It suggests that humanity was never a single fixed shape, but a spectrum. On one end, tall, long-limbed hunter-gatherers chasing herds across continents. On another, small island-dwelling toolmakers living in pockets of forest and cave, all of them walking upright, all of them facing fear, scarcity, danger, all of them solving problems with something more than instinct. The Hobbits remind us that evolution doesn't aim for a single best design. It simply tests what works in each place, at each time. On Flores, being little worked. A smaller body needs fewer calories, which matters on an island with limited resources. Perhaps a smaller body could move more easily through thick vegetation, scramble up steep ravines, slip into narrow cave passages. Natural selection doesn't care if that body looks advanced or primitive by our standards. It cares if you survive long enough to have children. In that light, the Hobbits are not an evolutionary mistake. They're one solution among many, a different way of being human-shaped. And that has implications far beyond one Indonesian island. It forces researchers to ask new questions. If such a surprising species could survive in plain sight for so long on Flores, what else might be hiding in the gaps of the fossil record? Are there other islands that once held their own unique humans? Are there mountain valleys, deserts, underground caves, where tiny branches of our family tree briefly flourished and then vanished, leaving only a few bones or none at all? The discovery of Homo floresiensis helped sharpen the eyes of paleoanthropologists. After 2004, strange bones that might once have been brushed aside as pathological or unimportant suddenly became potential clues to unknown species. Flores gave scientists permission to imagine a messier, more interesting past. Homo luzonensis in the Philippines is a perfect example. In another era, those fragments might have been forced into an existing category, squeezed under the label of modern human variation, or filed away as unusual specimens. Instead, the discovery on Flores had already cracked the door open. Researchers were ready to consider that another small island in Southeast Asia could host its own evolutionary story. In this sense, the Hobbits didn't just change our picture of the past, they changed the way we search for it. They also offer a strangely humbling comfort. For most of our history we weren't alone. We shared the planet with other humans who were not quite us, but not utterly alien either. Some of them we met, some of them we mated with, some of them, like the Hobbits, we may only have watched from a distance, or never encountered at all. The idea that somewhere deep in the Pleistocene night, a group of modern humans might have seen small, firelit figures moving at the mouth of a distant cave, it's speculation, but not impossible. If the dates overlap, as some evidence suggests they might, then at least for a flicker of time, two very different kinds of humans could have gazed out at the same stars, listening to the same night sounds, nursing their own separate fears and hopes, and then one of those kinds of humans disappeared. We don't yet know why the Hobbits vanished. Climate shifts, volcanic activity, competition with modern humans, disease, sheer bad luck. Any or all of these could have played a role. What we do know is that by the time recorded history begins, they are gone. So are the Denisovans. So are the Neanderthals. So perhaps are many other lineages we haven't even found. Only one branch of that crowded family tree is left. Ours. But the Hobbits whisper that this survival doesn't make us inevitable, or superior, or destined. It makes us fortunate. We are the last custodians of a story that was once told in many voices, in many bodies, across many landscapes. When we hold a cast of the LB1 skull, or look at a photograph of those delicate wrist bones, we're seeing not just a curiosity, but a reminder of everything evolution tried. Ongoing work on Flores continues quietly. Dating methods are refined, sediments are reanalyzed, new caves are explored. Researchers sift through layers of earth hoping for one more tooth, one more fragment of jaw, one more stone flake that might extend the timeline or clarify the ancestry. Similar searches unfold on Luzon, in Sulawesi, on other islands scattered across the Indonesian and Philippine archipelagos. Each new find has the potential to redraw our mental map of human diversity, to show that our species is just one variation on a theme that nature composed and recomposed for millions of years. That theme is not big-brained conqueror of the world, it's improviser, survivor, sharer of knowledge, maker of meaning. The hobbits of Flores, with their small frames and puzzling skulls, participate fully in that theme. They teach us that humanity is not one face but many, not one path, but a web of paths crossing and recrossing through deep time, and somewhere, beneath layers of rock and ash and forgotten forest, more of those paths are still waiting to be found. So here we are, at the end of the path that started in 2003, when a small team walked into a cave on a quiet Indonesian island and came back out with a skull that shouldn't have existed. At the time, the textbook said we already knew the broad outline of our family tree. There were the classic ancestors, the familiar branches, the expected timelines. And then LB1 appeared, barely over a meter tall with a brain the size of a grapefruit, living tens of thousands of years later than anyone thought possible for a human that primitive. From that moment on, everything was up for renegotiation. Since then, researchers have measured every millimeter of those bones, scanned every curve of that tiny skull, sifted every layer of sediment from the cave floor. They've argued about island dwarfism and brain evolution, about stone tools and fire use, about whether this was a diseased modern human or a completely different kind of person. Step by step, year by year, the picture sharpened. Most lines of evidence now point to a real, distinct species, small in body, small in brain, but skilled, persistent, and clever enough to make stone tools and survive on a rugged island for possibly hundreds of thousands of years. And yet, for every question that's been answered, two more have quietly taken its place. We still don't know exactly where the hobbits came from. Were they descendants of an early wave of Homo erectus who shrank over time, shaped by the strange rules of island evolution? Or do they trace back to something even older, an unexpected offshoot of a more ancient human line that wandered farther than we ever imagined? We don't know what they sounded like when they called to each other across the forest, or how they thought about the world, or whether they watched the stars from the mouth of Liang Bua on clear tropical nights. We may never know if our own ancestors met them face to face. The timelines overlap just enough to make it possible, but not enough to make it certain. It's a door left half open, a question that might linger forever at the edge of what evidence can show. And that's the quiet power of Flores. Because if a whole species of tiny humans could hide on one island until 60,000, maybe even 50,000 years ago, what else is waiting, sealed in caves and riverbanks and limestone pockets across Indonesia? There are thousands of islands scattered across that archipelago, each with its own caves, its own fossils, its own chapters of history still unread. Flores gave us hobbits, Sulawesi, Timor, Borneo, New Guinea. Any one of them might be hiding another surprise, another cousin we've never met, another version of human that bends our definitions even further. The hobbits remind us that our story isn't neat or linear. It isn't a straight ladder climbing cleanly from primitive to advanced. It's a tangled forest of paths, some wide and well lit, some narrow and overgrown, some ending in shadows we may never fully explore. Flores is one of those shadowy paths, and every bone, every tool, every grain of ancient ash whispered out of Liangbois pulls us a little deeper into the mystery. As you settle in now, you can let that thought drift with you, that the ground beneath our feet is full of secrets, that whole kinds of people once walked this earth, laughed and feared and struggled, and then vanished, leaving only a handful of clues and a long echo of questions. If you've enjoyed wandering through this strange corner of our family history, you can gently tap like or subscribe so you don't miss the next story from the deep past. If you feel like sharing, you can leave a comment about where you're listening from, what part of the world you're in, as we lie here together, thinking about a tiny woman from a cave on a faraway island. For now, you don't need to solve the mystery. You don't need to pick a side in the debates, or remember the dates, or hold on to every detail. You can just rest with the idea that our family is bigger, stranger, and more wonderful than we once believed. That somewhere, in dark caves and quiet valleys, more pieces of the puzzle are waiting. Let your thoughts drift to those little hobbits of Flores, moving through the forest by firelight, stone tools in hand, part of a human story that still isn't finished. And as the questions fade softly into the background, you can follow them into the dark, into that gentle, endless space where mysteries don't need answers, and the past can simply keep on dreaming.